Hello, hello, hello. Here we go. The central question for this video is going to be, how do you add or subtract rational expressions? Oh baby, here we go. Now, as you notice behind me, when and only when can we add or subtract fractions? Notice it doesn't say rational expressions, it just says in general fractions. This is not my essential question, although I can tell you it is a huge question. So think about it. When can I do it? Did you get the subtle hint? That was the second time. Did you see it again? I think you got the idea. You must have common denominators. I don't care if you're adding or subtracting, either way, you cannot do it unless you have common denominators. Now you just saw in the last section, in the last couple videos, if you're multiplying or dividing, it doesn't matter what the denominators are. Man, you rock and roll. However, when you're adding and subtracting, you better make sure that you have, that was the fourth time, I hope you got it by now, common denominators. So here we go. Let's rock and roll. Okay. So what happens if we're given a simple rational expression, rational expression, where we're adding them or subtracting them and they already have common denominators? So if the denominators are already the same. Well, if you look here, it's a simple question. You got 4 over 3x, a simple rational expression, plus 5 over 3x, a simple rational expression. Since they have common denominators, remember the rule is in any fraction when you're adding, you add the numerators, which gives you a 9, and you keep the denominators exactly the same. You don't add these and get 6x, you just keep them the same and you get 3x. Now this one you can do something a little special with, because there's a 9 on top and there's a 3x on the bottom. You can actually reduce this. This would reduce because you could divide the top by a 3 and the bottom by a 3, which cancels this out, which makes this top part a 3. And these are gone, so it just means it's an x. So you can reduce the 9/3, 9 over 3, to 3 over 1, which is just a final answer for this one, 3 over x. Sweet! That's rock and roll. Okay, so over here to the right, you see this one, x plus 3. X plus 3 is my denominator. Denominators are the same, so phenomenal. All I do is I keep the denominators exactly the same, so x plus 3 is going to be down here. And then is, be careful, this one's a subtract. So I have to take 3x plus 4, and I must subtract away the 4. So I always tell people, let's do this. Let's just write it down this way. 3x plus 4 is the top, minus whatever is over here, so it's all this stuff. It's a 4. Now that's going to come into play in a little bit. You'll see. So 3x plus 4 minus 4, well, that's actually simple. This just disappears because that goes to a 0. So really what I'm left with in this one is 3x over x plus 3. And that, ladies and gentlemen, is my final answer for that one. Now down here we got a pretty cool situation. Notice the denominators, exactly the same. Factor, 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 exactly the same. So therefore I would keep my denominators exactly the same. X minus 1, x plus 3. Now in this one, oh boy, I have to actually take and add these things together. Now I can cut out a couple steps here, really, if you look at it. I can take the like terms, and add those bad boys together. So negative 2x squared and a 3x squared just gives me x squared. And then I can take the negative 7, add negative 2. Negative 7 plus negative 2 gives me negative 9. Be careful now, this, ladies and gentlemen, is not my final answer. Ha-ha, tricked you. Because you can look at this binomial in the top, and it's a subtraction. Oh, it's the difference. And I can square root both of these. So that's the difference of two squares. So I can actually factor that. Let's come down here and show you. That means I go x minus 3, x plus 3. That's what this binomial factors into, the difference of two squares. And then the denominator still stays the same. Uh-oh, I see something pretty cool. Oh, buddy. I see an x plus 3 on top, and I see an x plus 3 on the bottom, so they cancel each other out. Sweetness. So I get x minus 3 on the top, and x minus 1 on the bottom. And ladies and gentlemen, welcome to your answer. So there you go. Same denominators, keep the denominators the same, keep the denominators the same, keep the denominators the same. Just add across the numerators, add across subtract the numerators, add across the numerators. Sometimes you got to simplify a little bit more. It is how it works. They are the easy ones. Let's get to the more fun ones. Notice I didn't say difficult. I said more fun. So what happens if the denominators are not the same? Well, here's my 6 things I would tell you to write down on your sheet of paper or your notes. Step number 1, factor the denominator as much as you possibly can. Both denominators, or all 3 denominators, depends how many there are. First thing you want to check for is GCF, and then you're going to factor the binomial, if there is one in the denominator. Look for difference of 2 squares, and factor the trinomial. As we talked about in class, use your Xbox method. Next step, construct the common denominator. You'll see how that works here in the examples that we do. Next step, multiply by what's missing. You're going to check each particular rational expression and kind of see what's missing in the denominators, comparing it to my common denominator. You'll see again in an example. Then you're going to add or subtract across the numerators like we just did in the previous ones. You're going to keep the denominators exactly the same. Denominator stays the same. And then we're just going to simplify and clean it up if we possibly can. So there are your 6 steps. Hope you got those down, because I'm not going to refer back to them in this video. You can look at your notes as we go through this next example. So let's do one where we do not have denominators that are the same. You're going to see me now. I'm going to parallel 2 examples for you. A simple example and a rational expression example. Now you're going to see in both of these, though, right away from the get-go, not Geico, get-go, 6, 2. My denominators are not the same. Oh no. Over here to the right, certainly they're not the same. X squared plus x minus 2 and x plus 2. They're not the same. Let's use our steps to get these things the same so we can actually add these things together. Here we go. Step number 1. Factor the denominator as much as we possibly can. Well, 6, you can factor that and write it into 2 factors of 2 and 3. They are the factors of 6. 2, there's nothing I can do with it, so it just stays 2. Same concept right here. X squared plus x minus 2. Use your Xbox method we talked about in class, or whatever method you want, but it factors into these 2 binomials. X plus 2 times x minus 1. So there's my 2 factors, just like these are, of 6. It's my 2 factors of this guy. So over here to the right, that's a binomial, but it's not the difference, so I can't do anything with it. It stays x plus 2. There's step number 1. On to step number 2. Constructing the actual common denominator. Now, I'm going to tell you, this is probably the most important step to get the question correct. So here's how I kind of do it. In constructing my common denominator, it implies exactly that. You want the denominator the same for all of the denominators that you have in the problem. So I kind of look at it this way. I say, okay, in this denominator, I know I need a factor of a 2. So I need a 2, at least in my overall denominator of everything. Over here to the left, I have a 2. Oh, wait, I got that taken care of because the 2 in this denominator. There's the 2, so I'm good. But I am missing a factor of a 3. So I need that also in my common denominator of all of my denominators. So there's my common denominator, 2 times 3, or as you know is 6. That's paralleled over here. Well, I have x plus 2, x minus 1, and I have x plus 2. Well, let's start with this one. I know I at least need x plus 2 as part of my common denominator. Well, if I have x plus 2, let's compare it over here. Well, I have an x plus 2 in this one, but I also need this guy. I'm missing an x minus 1 in my common denominator. So I need that as part of my common denominator. So there we go. So I have x plus 2, x minus 1. That's taken care of. That's taken care of. 2 times 3. That's taken care of. That's taken care of. Sweet. So we got step number 2. Let's roll on to number 3.